Okay, so we have been working on some pretty advanced equations recently using these wonderful hanger balances from Illustrative Math. And I am going to do one with you here so that way you can practice on your own. Just to review, we have been working a lot with the distributive property, and we've been doing a lot with combining like terms. And remember, the distributive property is a property that allows us to multiply quantities on either side of the addition or subtraction sign within the parentheses. And you've been doing distributive property from way back when you were in elementary school and you did 26 times 4, and you would take the number 26 and break it down into 20 plus 6, and you would multiply that by 4. Okay, so just algebraically we would say 4 times 20 plus 4 times 6. Okay, and again, you have done a lot with this. Now we're just doing this with variables. So we know we have a y plus 4 and a y plus 4, which is the same thing as 2 y plus 4s. And then if we're multiplying both of those, we have 2 y's and we have 2 4s. Oh, messed up there. Don't forget to do that. Haha, that's a big one. So remember, when you're multiplying 2 y's, you also have to multiply the second number as well. That was an easy mistake. And again, writing it out like this is also really good. You can see y plus 4 and y plus 4. I have 2 y's and I have 2 4's. 2y plus 8. Okay, so distributive property. We also have been talking about combining like terms. And combining like terms, remember, we are looking for our x variables, or y, or m, or b, whatever the variable is. Remember, we have to keep our variables that are the same together. That's why it's called like terms. 2x plus 7x is 9x. So I have 2x's and I combine them with 7x's, and altogether I have 9x's. But then I have this 3 and 5, and they are missing the variable. So we don't want to combine them with numbers that have variables. So 3 plus 5 is 8. So 9x plus 8. All we've done is simplified this expression. All right, so both of those are going to come in handy when we do this next equation. Now, in illustrative math, they have one here that you can use. This is a really good one. I'm going to do another one that's similar to this one, but a little different. Okay, so this one is here. I'm going to make my screen a little bit bigger, but we're going to come back to this one. All right, so let's go to slide this over. All right, here we go. Let's kind of move this so we can see both for a little bit. Got my markers ready, and here we go. I'm going to create a hanger balance. And I'm going to use colors for this because I just in the mood to color code. All right, my color codes, I'm going to have 4, 4, 4, and 4. And then on the other side of the scale, I'm going to have an X and a 3. An X and a 3. Now, we did something very similar to this in class, and we listed all the different ways that we could represent this equation. Because remember, whenever we're working with these hanger balances, these are great, and it's a great tool, but we should get into the habit of representing this algebraically. All right, so there were a couple things that we listed, and I'm going to list the ones that came up in class. So I'm just going to list this because this was one we kind of did together in class. We said x plus 3 plus x plus 3, and I'm just putting parentheses around to organize it, is equal to 4 plus 4 plus 4. I'm going to squeeze it in there, plus 4. Whew, got it in there. Okay, so let me zoom in a little bit here. All right, now I can represent this in an easier way because this is a little redundant, right? Everybody looked at this and was like, Miss Breen, this is 16. So, I mean, I have x plus 3, and I have x plus 3, and I could say 16, okay? Or I could say 4 groups of 4, right? 4 times 4. 4 plus 4 plus 4, 16, 4 plus 4 times 4. However, if we're combining like terms, 16 is the easiest to work with. Now, look at the x's and the 3's. We have the distributive property going on here. So here's a group, right? X plus 3, and here's another group of x plus 3. So I technically have two groups of x plus 3. So this would be one way that we could represent it, and that equals 16. All right, so I'm going to solve it like this first. So I have my equation 2 times x plus 3, and that equals 16. Okay, so one way we can solve this problem, is to leave it this way, okay? Leave it with the distributive property. And I notice I have 2 and 2, so x3, 4, 4, 4, 4. So watch what happens if I just divide the whole thing in half, okay? And I get rid of half of the scale. So if I divide the whole thing by 2, so I'm going to divide this by 2, and I'm going to divide this by 2. No longer do I have 2x plus 3's. I only have 1. That's because 2 divided by 2 is 1. So they're dividing by each other, leaving me with just x plus 3. That's all I got, right? X plus 3. And then 16 divided by 2 is going to leave me with 8. Isn't that cool? All right, so I've just literally eliminated half of my scale. And what do I have left? X plus 3 is equal to 8. Well, now this becomes a very easy problem because I can do this mentally, but I can also say, well, look, if I take 3 away from both sides, okay, so I'm taking 3 away, and this is now 1. I have 5 on this scale, and I have x on this scale, so we can assume that x is equal to 5. Mathematically, this is what it looks like. Here's my 0 pair. X is equal to 5. Now, I can plug it in and do the test and just make sure this works out. Okay, 5 plus 3 is 8, and 2 times 8 equals 16. So I could come over here and I could do 5 plus 3, 5 plus 3, 5 plus 3 is 8. And I have 8 on both sides, and I could squeeze it in, okay? So if I really want to go the long way, I can do that. So x is equal to 5. Now, what if, instead of using the distributive property, I want to combine like terms? This is just how my brain works. I like the distributive property, but I am a big fan of combine like terms. All right, so I'm going to do another sketch real quick. And I'm going to go ahead and combine these terms. All right, so obviously 4 plus 4 plus 4 plus 4 is 16. That I just combined like terms. They're all the same, so I combined them. And over here on this side, instead of splitting them up, I'm going to put my x's together. And I'm going to put my numbers together. So my equation that I could write is 2 x's and 3 plus 3, which is 6. So I could say that this is 2x plus 6 is equal to 16. Now we're going to look at this a different way. So now what I have is a two-step equation, which is what we worked on last class. And I can eliminate my 6, just get rid of this whole thing. Minus 6, take 6 away, take 6 away. There's my 0 pair. That leaves me with 2x is equal to 10. Okay, now, if you need to, again, like I told my other class, it's no shame in resketching. So now instead of having this 16, it's actually 2x, and instead of 16, I have a 10. Now, I can just cut it right in half. So if I take my 2x's and cut it in half, and my 10 and cut it in half, divide both sides by 2. 2 divided by 2 is 1, 1x. 10 divided by 2 is 5. All right, let's test it out. Okay, let's use our original equation. 2 times 5 plus 6. Does that equal 16? 2 times 5 is 10. 10 plus 6 is 16. Check. It worked. So, the beauty of these, and I'm going to kind of zoom out a little so you can see the whole thing. The beauty of these hanger scales, the hanger illustrative math hanger balances, is that you can actually look at this solving these equations using the distributive property or combining like terms. That's where you have to figure out as a student which one works best for you. I personally like combining like terms and then solving. Now, in our example on illustrative math, there's a really good one here, and they walk you through the steps to show you. Here is our x plus 2, x plus 2, x plus 2, or 3 groups of x plus 2, and it's equal to 18. And they show you how you can work it out multiple ways. So again, beautiful illustration of how we can use the distributive property or combining like terms to solve multi-step equations.